Dear students, welcome to all. Now we are going to see the concept of timing diagrams of 8086 microprocessor. This is for general bus operation. These timing diagrams are common to your maximum mode as well as the minimum mode. And if you see here, you are having the 5 clock cycles T1, T2, T3, TW, T4. These 5 clock cycles are for memory read cycle. Next 5 clock cycles are for memory write cycle. Okay, why we have taken the 4 clock cycles here means irrespective of if you leave the waiting states, in order to execute one instruction in 8086 you are requiring the 4 clock cycles. Okay, for execution of one instruction in 8086 you require 4 clock cycles. Because of that we have drawn the 4 clock cycles. Then why we introduced the wait state in between T3 and T4 means the actual data transfer is going to take place in between the T3 and T4. Because of that we need to introduce the wait states in between the T3 and T4. What is the purpose of the wait state? Means if there is any speed mismatch between the two devices, so because of that we need to introduce some wait states. Okay, that too during the data transfer only we are getting the speed mismatch now. That's why we are going to introduce the wait state in between the T3 and T4. Now we will see the first timing diagram, that is ALE. ALE means address latch enable. Address latch enable is active during the T1 cycle only. ALE is active during T1 clock cycle and inactive for both read operation as well as for write operation. It is active during T1 cycle and it is active during the remaining all clock cycles. Okay, remaining all clock cycles it is inactive. You can join this one in this manner. Okay, this is the timing diagram for ALE. Means ALE is 1 during the T1. Remaining all clock cycles it is 0. Okay, and here the same for right cycle. ALE is equal to 1 during the T1. Remaining all clock cycles it is 0. Okay, and whenever ALE is equal to 1, here if ALE is equal to 1 then address will be activated. Okay, if ALE is equal to 0 data bus will be activated. Now we will draw the multiplex lines of address as well as the data. First we will say take the timing diagram for the address as well as for data. Okay, if a during the ALE1 ఇక్కడ ALE1 అయింది కాబట్టి here address bus will be active. Here address bus is active. Let it be the address bus, and the same for the write operation also. Address bus is active. Remaining clock cycles it is inactive. Remaining clock cycles it is inactive. You can join this like this. You can join like this. This is the timing diagram for address. Whenever ALE is equal to 1, address is 1. Remaining all clock cycles address is inactive. Again for right cycle ALE during ALE 1 the address is active. ALE 0 address is inactive. Now we will draw the data line. ఇక్కడ ALE 1 అయినప్పుడు అడ్రస్ యాక్టివ్గా ఉంది కదా, కాబట్టి ఆబ్వియస్గా ఇక్కడ డేటా ఏమవ్వాలి, మనకి లో ఉండాలి. కాబట్టి యూ కెన్ డ్రా ద మల్టీప్లెక్స్ లైన్ లైక్ దిస్. This is data. This combinedly call it as address and data. Okay, and now it will become active during remaining clock cycles. Again it is inactive during T1 and active during remaining clock cycles. Okay, if you see this is A0 to A15, this is D0 to D15, again it is A0 to A15, again it is D0 to D15. Means Whenever AL is equal to 1, address is activated. If AL is, during AL is 0, data is activated. Is it satisfied or not? Yes. Again AL 1, address is activated. If AL is 0, data is activated. Now we will see the multiplexer lines for address as well as the status lines. Okay. Similarly, the address concept is same. During T1 it is high. For remaining clock cycles it is low. Again during for write operation address is high. For remaining clock cycles it is low. This is address. Now draw the status lines. ఇక్కడ అడ్రస్ యాక్టివ్ ఉంది కాబట్టి సేమ్ స్టేటస్ ఇన్యాక్టివ్, అడ్రస్ ఇన్యాక్టివ్ కాబట్టి స్టేటస్ యాక్టివ్, the same in the write operation. Okay, this is for A16 to A19. Okay, and this is for S3 to S7. Again A16 to A19, S3 to S7. These are the address and status multiplexer line timing diagram. Okay, and now we will draw the status lines. We are having total 20 address lines now. A0 to A19 we covered, and data lines 16, D0 to D15 we covered, and status lines are of 8, S3 to S7 covered. Now we will cover the S0 bar to S2 bar, 3 lines. Okay, S0 to S2 bar, these status lines are active during the T1 and T2. Active means what? This is active low or active high signals. S0 to S2 bar is there na, therefore these are active low signals. అంటే ఇది యాక్టివ్ అవ్వాలి అంటే these must be low. ఓకే, కాబట్టి యాక్టివ్ అవ్వాలంటే డ్యూరింగ్ T1 to T2 it is low, remaining clock cycles it is high. Okay, and the same for these also. During T1 and T2 these are active, remaining clock cycles inactive. This is the timing waveform for the status lines. See, if you, I am summarizing here. During T1 and T2 S0 to S2 bar are active, remaining it is inactive. Active means these must be active logic low. Okay, and inactive means these must be logic high. Okay, now we will draw the timing diagram for timing waveform for read bar. Read bar is associated with the read cycle only. Read bar is associated with the read cycle, not, it is not irrespective of the write cycle. So it is logic low signal, means read bar is active during T3 and T4. Okay, means these must be active, means it should be logic low. Logic low undali during T3 and T4. Remaining clock cycle it is high. Okay, for write cycle it is inactive, only read operation. For read cycle it must be low, for write cycle it must be high. Okay, this is the read bar. Read bar means during T3 and T4 it must be low. Okay, and next we will draw for the write bar. Write bar is associated with write cycle. This is also logic low signal, so during T3 and T4 it must be low, remaining all clock cycles it is high. Okay, this is the timing waveform for the write bar. Now we will see one more, that is dt by r bar. Dt means data transmit and receive. Transmit means it is for write. Okay, receive means it is for read associated. So r read, you can remember in that way. Receive for read, transmit for write. Okay, now R bar is related to the read cycle. Na? R bar is there, it is active low, it is active low signal. So during entire read operation it must be low. During entire operation it must be low. Transmit is associated with the write cycle. During entire operation, entire all clock cycles it is high. Okay, this is the dt by r bar. And last one, data enable pin. If you enable this one, then only data transfer will take place. Okay, for this to enable data transfer actually taking place in between the T3 and T4. So it is active low signal. So during T3 and T4 you can make it low, and during T3 and T4 you can make it low for write operation. Remaining clock cycles it is high. Okay, this is the complete timing diagram for the general bus operation. This is the same for maximum mode as well as for the minimum mode operation of 8086. You can split into separate either read cycle as well as for the write cycle. Okay, I hope you all of you understand. Thank you so much.